Shortest job first, SJF scheduling. Shortest job first scheduling works on the process with the shortest burst time or duration first. It is best approach to minimize waiting time, and it is also used in batch systems. There are two types, the non-preemptive and the preemptive. So what I'm going to show you is the preemptive way of making the shortest job first. So here, this is the given. There are four processes with corresponding arrival time and burst times. So first, I have made a Gantt chart to visualize the shortest job first. So the condition is that if the arrival time has been realized and the burst time takes longer than other process, it actually skips to that specific process because it prioritizes the shortest job first. So at the first scenario, we are faced with P1 which has 12. So its arrival time is 0, and the nearest arrival time that we'll be getting is from 2 milliseconds. So it is free to do whatever it wants. So after 2 milliseconds, process 2 will exist. Now, the problem is that the burst time of P1 will take longer. So if you think about it, if P1 will actually proceed, then the P2 will be delayed very drastically, since its arrival time should always be in 2. Should be in 2. And since we are working on a shortest job first, we need to prioritize the shortest process that we can manage. So we actually mark 2 as our CPU. We actually put the CPU into process 2 because shortest job is the priority. As you can see, there is 10 here. It is because before, from 0 until to the next process, it actually reduces the process burst time. So as you can see here, it's from 0, and it actually is it doesn't have any problems until the second millisecond. So we subtract the original burst time into 2, so we'll get 10 as the burst time, meaning it's the remaining time that we'll have to execute P1. So P2 will also encounter other processes, like in the third process, it actually have an arrival time of 3 milliseconds, which is just 1 millisecond away. So it satisfied one block of, as you can see here, like a block of millisecond. So it is now subtracted. The P2 is now subtracted here. So from 4 it will go to 3, since it actually is running 1 bit of code. Now we notice, if we compare this burst time, P2 will still be the better one. So with the rule of shortest job first, we run the shortest job, which is the P2. Now the process 3 will have to remain. Now at the next set, we are now faced with this one. The process 2 is already finished, so it can't be bothered anymore. The process 3 should have been run at the third millisecond, yet it has been postponed. It has been preempted because of this. Actually, not preempted. It hasn't started yet. The preempted one is it started, but it can be paused and run afterwards. So as we can see, if we compare P3 to P4, if we compare P3 to P4, P3 has the least amount of burst time, and P3 has the third millisecond, which is we are already past it, but P4 we haven't arrived yet, so P3 will be the next one to execute. As we take a look at this, it has 6 burst time. So from 6, which is the door of the opening for the P3 to go, it actually jumps to 2 milliseconds until it reaches 8, which is the 8 millisecond the P4 should exist. But now the shortest job now is the P3, since it is subtracted by 2 because of this. So what we are going to do is we continue P3 until it is finished. So we should mark this as check, actually here. Oh no, here. This is the right one. Wait, let's just write this here as well. So P3 has been satisfied at 12 milliseconds, which is so far from the arrival time, which is 8 milliseconds. But the shortest job first rule is to prioritize the shortest job first. So now the next condition is from P4 to P1. So which has the bigger burst time? The bigger burst time is from P1. So P1 will have to wait for P4, which is 5. Since it needs to run for 5 milliseconds, it actually satisfies this from the opening that P3 has created. Then since the last one is P1, it will actually run without any trouble at all, because there are nothing to prioritize than the P1. That's all, sir. Thank you.